Hello, welcome to Unit 11C, Systems of Equations and Their Solutions. In this unit, we're going to talk a little bit about what kinds of solutions that we can get when we're solving systems of equations, and systems of two equations specifically. So let's look at determining the number of solutions. We've seen a number of examples so far that are pretty straightforward. We've got two equations and they represent two lines on a graph and they intersect at 1, 3. This equation has one solution and we can name it, and we've been working with that in previous videos. Let's talk about a different situation here. Y equals 2x plus 6 and y equals 2x plus 1. We have these two lines here, and they're all set up where we can do our process of elimination. We'll take that second equation and multiply it by a -1, giving us negative y, negative 2x, and negative 1. And now let's add those down. Y and negative y is going to leave us with nothing on the left-hand side, and being a good mathematician, I'm going to represent nothing with a 0. On the right-hand side, 2x minus 2x leaves us with nothing, plus 6 minus 1 leaves us with 5. Our final equation that we're trying to solve here ends up being 0 equals 5. In what universe does 0 equal 5? Well, not my universe for sure. That means there is no solution to this problem. We have a nonsensical equation here to work with, and therefore there is no solution, and that is a valid answer in mathematics. Let's look at a final situation. Here we have a set of two equations, y equals negative x plus 4, 2y equals minus 2x plus 8. We're going to take that first equation and multiply it by 2, 2y equals negative 2x plus 8, and now we can add those together. Oh, wait a minute, I'm not going to add those together. Look, it's the same equation. These equations are equivalent to each other, just written in different formats. What does that mean? If it's the same equation, that means it's the same line. And there are an infinite number of solutions to this problem. For any given x that I plug into this equation, I'm going to get the same y back for both equations. That means that any valid x that I plug in would be a correct answer, would give me a particular y that would be a correct answer. And that's also an accepted number of solutions. Let's see what these look like on a graph. So here was our first example where we have two nice lines that are not parallel and not overlapping, and they intersect at 1, 3, giving us one solution. Here's our second example where our lines are in fact parallel but offset from each other, and they will never touch anywhere in the universe. That is no solution. And here's our third example, and you'll notice that there's only one line here. That's because it's the same line. This equation here, y equals negative x plus 4, will give you this line. And this equation here, 2y equals negative 2x plus 8, will also give you this line. There are an infinite number of solutions along those lines. So the number of solutions you can have when you have a system of equations is one solution, no solution, or infinite solutions. And that's talking about systems of equations and their solutions.